All right, so this lesson is an introduction to a new number system called complex numbers, and they include something called imaginary numbers. And so imaginary numbers came about as a result of needing to be able to take square roots of negatives. And so we define the imaginary unit I to just be the square root of -1. Because if you can take the square root of -1, you can take the square root of any negative number. And so if we think about what like I squared or I cubed or I fourth would be, I squared would then just be a real number again. It would be -1 without the square root. When you square a square root, they cancel each other out. And so a natural next question would be, what is I cubed? And so I cubed is the same thing as I times I squared. And we just talked about how I squared was the same as -1. And so this simplifies to just -I. So if you cube I, you end up with -I. And then if you ask yourself, what is I to the fourth power? Well, that's really the same thing as I squared times I squared. Both would result in 4 copies of I being multiplied. And so I squared is just -1 times -1, which we know is +1. So if you raise I to the fourth power, you're going to get +1. And then if we take I to the fifth power, that's really I times I4. And we just talked about how I4 is 1. And so we're right back to what? I. And then I to the 6 is I to the 5th times another copy of I. And I to the 5th we know is just I times that copy of I. And so now we're back to I squared, which is -1. I to the 7th would be I to the 6th times another copy of I. I to the 6th is -1. And then we have I, and so we're back to -I. And then I to the 8th is I to the 7th times another copy of I. And I to the 7th is -I. I times I is -I squared, which is -1. And we're back to +1. So you might be realizing we have a cycle going on here. We go from I, if we square it, it's -1. If we raise it to the third power, it's -I, and the fourth power is 1. And then every time we get to a fourth power, we're back to 1. So it repeats every fourth power. Okay, and so that will help us simplify higher powers of I, because we just need to figure out what would be the exponent if we divide it by 4. And so if I take I to the 400th power, that's divisible by 4, and so that would be the same as I to the 4th, which would give us 1. If we wanted to take a I to the 17th, for example, we just need to see what the remainder is if we divide the exponent by 17. Divide the exponent by 4. And so here our exponent is 17, so if I divide that by 4, 4 times 4 is 16, so we would have a remainder of 1. With that remainder of 1, that means I to the 17th is going to be equal to I to the 1st, which we know is just I. For the 27, same thing. Take that 27, divide it by 4, and we know 4 times 6 would get us to 24, but that would leave us with a remainder of 3. So I to the 27th would be equal to whatever I cubed would be. And so whatever your remainder is, that's the power of I it is equal to. And so here my remainder was 3, and so it's equal to I to the 3rd. And so we know I to the 3rd is -I from the work we did above. And so you really just have to memorize these top 4, and then you can do any power of I by just seeing what the remainder is when you divide the exponent by 4. The other important thing we have to do with I is take square roots of negatives. That's going to come up when we start using the quadratic formula. And so this uses a property of square roots that if you have a product under a square root, you can break up that product into their each individual square roots. And so with this -4, we could rewrite that as -1 times +4. And then if I break them up into their own individual square roots, we know the square root of -1 is I. We know the square root of 4 is 2. And so we would simplify this to 2i. Always write the real number before the imaginary. And so similarly, we can do the same thing with the 9. Separate it into -1 times +9. Break them up into their own square roots. And then we know that's I times 3, which would be 3i. And so every time you have a negative, you essentially just need to take an I out of the radical and then treat it like the positive. So you can skip to that step. So for this next one, I know it's going to be I square root of 16, which would simplify to 4i. Here I would have I square root of +25, which would be 5i. Here I have I square root of 36. Need to switch colors. I square root of 36, which is 6i. And then here I square root of 49, which is 7i. So essentially, if you see a negative under the radical, you just take an I out and treat it like a positive. And so this helps us solve quadratic equations. So before, when we have x squared equals 16, we square root both sides. And whenever you square root both sides, to undo a square, you need the positive and negative. And so this would give us positive negative square root of 16, which is 4. So we can do the same thing even if the radical is negative. Take the square root of both sides, but this time we now need to take an I out and then simplify. So this would be positive negative 4i for our answer. Okay, and so for the rest of these practices, we're just going to practice simplifying powers of I and also just simplifying square roots. And so for this first example, you treat I very much like a variable, like x. And so if I had -3x times 8x, I would get -24x squared. The same thing with I. I get -24i squared. But you have to remember, every time you see an I squared, that's equivalent to -1. And so this is really just positive 24. Over here, same thing, 3 times 6 is 18, and then we would have I to the 4th. And we know when we see I to the 4th, that's the same as positive 1 from the work we did above. And so this simplifies to 18. All right, over here, following the rules of PEMDAS, you need to take care of this exponent first. And so what I like to do when I see squared is I write whatever's being squared twice. Okay, so 4i cubed squared is 4i cubed times itself. And so whenever you have a multiplication strand, you multiply the big numbers, the coefficients, and bring them out front. So 2 times 4 is 8, times 4 is 32. And then for the copies of I, you just add up how many copies. I have 1 copy, 3 copies, 3 more copies. That's a total of 7 copies of I. Okay, and since I to the 7th is equivalent to I cubed, because there's a remainder of 3 when I divide it by 4, I know this is going to be the same as -I, which we put the negative in front of the 32 for our final answer. That one was hard, a lot of steps. Okay, and so this is an Algebra 1 problem where you're just simplifying square roots. Remember, you're always looking to break it up into a product that involves a perfect square. And so I can break 24 into 4 times 6, and we know square root of 4 is just 2. So I'm going to take a 2 out, and this would simplify to 2 square roots of 6. Always make sure there's no more perfect square factors left under the radical. I can break 6 into 2 times 3. And that's the best I can do. Those are prime, they're not perfect squares, so this is simplified. Okay, for now, we're going to kind of ignore variables under the radical. We're going to get to those later when we do exponent rules. And so for now, we'll just worry about numbers and negative numbers. And so here I see a negative under the radical, so I'm going to take an I out. And then we have to simplify 24. We just did that with 4 times 6. And so that means we can also take a 2 out to join the I. And then the 6 would stay behind. Okay, and then here, take your I out. And then square root of 36 is just 6. And so that would simplify nicely to 6i, no radical left. When they're perfect squares, you're not going to have a square root left in your final answer. Okay, and so we can practice simplifying these. Take an I out, square root of 98. And then 98 is 49 times 2. And 49 is a perfect square, it's 7. And so I can take a 7 out to join the I and leave the 2 behind. Over here, there's a negative outside. You don't really do anything with that. Just treat it like a -1. But this negative inside means we're taking an I out. So we have a negative I outside. They don't cancel each other out. So just be very careful with that. Ignore this x to the 8th for now. And pretend it was just 48 in there. Okay, and so 48, we can break 48 into 8. Well, I struggle with my perfect squares. So that would be 4 times 12, and that would be 4 times 3. So we can take a 4, we can take 2 2's out, so that would be 4 times 4 times 3. So if we take a 2 out, and another 2 out, and then the I, we have a square root of 3. And so the simplified final answer would be -4i square roots of 3. We could have just done 16 times 48 to begin with, but I didn't, not 16 times 48, 16 times 3, but it wasn't coming to me. All right, here, just like we can break square roots up, we can also combine them together. And so if I do -6 times -10 under the radical, those negatives actually end up canceling out, and it takes us right back to an Algebra 1 problem. And so 60 is the same as 4 times 15. And so that means we can take a 2 out. And then 15 can't be simplified any further. It's just 3 times 5. So this is the best we can do. Okay, here, ignore the x to the 8. And then I can rewrite square root of 8 with the I out times the square root of 12. And this time I'm not going to combine them just because it's easy for me to break 8 apart. And so 4 times 2, and it's easy to break 12 apart, 4 times 3. And so I can take a 2 out of the first radical and leave a 2 behind. Take a 2 out of the second radical, leave the 3 behind. Bring those 2's out front, and you would have 4i. And then you would have square root of 2 and square root of 3. And so for your final answer, you would just combine them to 2 times 3 under the radical and get 4i. All right, last one is a fraction. Ignore the variables for now. Take your I out. And then when you're square rooting a fraction, kind of like with the product, you can take them each individually. And so square root of 25 is 5, and square root of 36 is 6. And so this would simplify to 5 over 6, which is just 5, 6i.